everyone. Karen Roby and Daphne Leprince-Ringuet here for ZDNet, talking today about the technology behind deepfakes. And Daphne, of course, we hear so much about deepfakes and some about the technology behind what's really going on here. So let's just start with, what you're learning is specifically and how this could be used for good.
So as you said, we do hear a lot about deepfakes. We hear maybe a bit less about the more technical name of the technology, which is generative adversarial networks, GANs. So it's a type of AI that uses a data set of videos and of images and sounds and comes up with hyper-realistic but fake content that increasingly gets hard to differentiate from authentic content. So as much as we know how GANs work, we don't really understand the inner workings of a GAN, how a GAN comes up with content, what the rules are for new content, and how a GAN really makes synthesized media as realistic as it does. So it's based on that observation that a team of researchers from MIT decided to sort of probe the inner workings of GANs to shed a bit of light on how the technology actually comes up with the new content. So it was a research team led by a scientist called David Bow, and what they did was that they took the neural network behind the GANs and they laid it down flat in order to be able to probe into the different connections and the different mathematical operations that are behind the technology. And what they found was that the way a GAN develops new content is based on different sets of neurons that all encode different features in an image or in an audio recording. So they were able to sort of identify a specific set of neurons that will, for example, say that a tree should go there, or that a door should go in the building entrance, or that a cloud should go in the sky. And they figured out that by editing these little sets of neurons, they were able to immediately affect the outcome of the AI system and the image that it eventually generated. So we're talking about very easy tasks: edit, copy, paste, delete. But if you figure out where in the GAN this connection is being made, the scientists figured that you were able to eventually change the way the output looked without having to change the data set that the GAN is being fed in the first place.
And Daphne, talk a little bit about how to actually change the wiring.
Yeah, so that was really interesting because as much as the scientists were able to change the little things, so change this set of neurons that encodes for this feature, as they experimented, they realized that the GAN sometimes would just not let them carry out certain operations. So if something was deemed too unrealistic by the system, it would just refuse to carry it out. It would veto it. So for example, if you asked it to draw a tree in the sky, nothing would happen. So Bo started asking himself, why is that? And he sort of probed deeper into the neural network, and he found out that if a GAN is fed enough pictures of clouds and enough pictures of trees, it eventually makes associations, and it figures out that trees go on the land, doors go in buildings, clouds go in the sky, and it won't depart from that, and it will want to copy that. So with his team, he was able to dig further into the GAN's sort of code and rewrite that memory so that these associations would be undone and that he would be able to change the output again. But it's a really interesting point in the first place that the GAN, using a data set that is fed by a human, will draw those associations and take them for granted and establish that this is how the world should look like without questioning it and really copying what it has been fed in the first place.
All right, very interesting. And finally, Daphne, talk a little bit about actual applications for if you're able to change the wiring, some real life applications of how it can be used.
Sure. So GANs, as we said, are usually thought of as a technology that is used for things like deep fakes, but that's not really what the team at MIT wanted to achieve by showing that you could, first of all, understand, and second of all, change the wiring of a GAN. I think the first thing that we're trying to do was just bring a bit more transparency to the technology in the first place, so that it doesn't happen in a sort of black box without really knowing how the images are created, how the audio content is created. But the second thing is that it allows for a lot more imagination to happen within the technology. So if you decide that you want to put a hat on a horse, or if you decide that you want to put a door in the sky, the GAN won't stop you from doing it. And I think what the researchers were pointing to is that it's quite frustrating that the GAN initially wouldn't give you that space to imagine things, create things, and bring them into the images. So Bo and his team are really hoping that the tool they've developed will be taken on by artists as a way to express their imagination and creativity. And it's certainly really exciting to imagine all the things that artists will be able to do using the technology in the future.
Yeah, most definitely. I'm sure the possibilities are endless. All right, Daphne. Well, for much more, of course, on this research, Daphne's full article can be found on ZDNet, and we hope all of you will check it out there. And thank you for watching.